Hey everybody, Dave Lindberg in Hong Kong with another episode of THD Podcast. And it seems like the theme at this time of year is test and measurement. So we're going to be talking with Echo Test and Measurement out of California. They do a lot of production line testing equipment for some big volume customers. So we're very interested to find about that. And thankfully, they are an ALTI member. So please, everybody, check out our sponsor, the ALTI Association, a great tool for industry networking and getting to know who's who in the scene. So let's get into it here. We have Simon, as always, in Japan. Good morning, Simon.
Morning, Dave. Evening, others.
Okay, yes, yeah. Matt's joining us in the afternoon, CTO of Echo Test and Measurement from somewhere, I think, Northern California. How are you doing today, Matt?
Santa Barbara.
Okay, Central, yeah, all right. Things are good?
Yeah. Glad to be here.
Okay, so yeah, Echo Test and Measurement. How long you guys been around, and tell us what you do.
There's been various incarnations of the company over the years. I think Echo was founded as Street Electronics in 1978.
Oh, wow.
The company founders. So that makes a good 45 years ago. I mean, I've been here for a while, but I haven't been here that long. I think back in the day, it was a medical device company. I think that was it's been reinvented and it's cycled. We have this joke that it's a 45-year-old startup where we kind of keep resetting and doing new things. How far back do you want to go? You want to talk about the Apple II? We can talk about the Apple II. I think the company's first big success was when I was in junior high, and the company founder Milo Street, he built I think it was a serial printer interface called the Grappler. That was a kind of a big deal back in the day. And then they built what was one of the first computer sound cards ever. It was a speech synthesis card for the Apple II that could talk, and it was great for schools. That was novel in 1982. That was a big deal that the computer could talk to you. And so that's and since then I think we've worked on just about everything from audio over Ethernet to Firewire. We worked with Gibson Guitar for a while on their self-tuning guitars. That was a lot of fun. Nobody wanted self-tuning guitars, it turned out, but that was a lot of fun. And now we're in this test and measurement field. So yeah, the company's kind of kept looping around and reinventing and recycling, and we take what we've built on and what we've learned and go again.
All right. Well, let's maybe talk about the current, and maybe we'll get into a presentation to walk people through what you guys do.
Yeah. So starting in around 2014, 2015, we started shipping a lot of our audio interfaces that we were making at the time, basically sound cards and audio and pro audio interfaces that were being put into large factories for testing audio equipment. And from that, we kind of worked with that company to develop a system designed just for them. And that became the first Echo AIO product, which is our current product line that we're selling. And it's, I guess the way to describe it is it's a sound card designed for test and measurement instead of an audio sound card being used for test and measurement that doesn't necessarily have the right inputs and outputs or the right interface capability with the computer. So we're taking that concept and we're turning it into Echo test and measurement hardware. So the AIO hardware. And it's usable with any software, any test software made by anybody that accepts ASIO as a driver or Wasapi or Core Audio, which is the Mac interface. So we can speak to everybody, and we make the hardware. We don't make the software, the test software. So that's kind of the overview of the product. And Matt, do you have a presentation slide you want to throw up just to show people a picture?
I think I'll add one little anecdote to all that, which is it all sort of came born out of misfortune, I suppose. I think, and the nice version of the story is we had a Firewire box that we were built, and actually I think that's in the presentation. I wonder if I could jump ahead a little bit here. Yeah, so this was the kind of the sound card, one of the flagship products that we had back in the day. This was like 2008, 2010 when people cared about Firewire. And when that was a going concern. And so this was a pretty straightforward box, 12 inputs, 12 outputs, line level balanced. You can see the Firewire, it's got MIDI, word clock, it's a pretty typical kind of rack mount pro audio interface box. And so we had a big customer that was using a lot of these for end-of-line production testing, and they started griping. They said, "Hey, they're failing in the field. They're having," and so we said, "Ship some of us back," and we got them. And it turned out they were using inexpensive 1/4-inch like guitar style cables, and they were breaking them off in the jacks here. Like they were getting back, and there was like just the tip of the cable was broken off in the jack. And we're like, I think there's your problem there. And so the thing that was born out of that was this idea, well, what if we just built you a box that was purpose built for end-of-line production testing? It was built for the factory environment. That this is really meant for studios and in your garage and recording your buddy's band and stuff like that. And that was the genesis of it all. But yeah, we can walk through the presentation. Let me roll back a little bit here. Okay. Yeah, Chris, do you want to walk through this? I think you might be more familiar with this than I am.
Yeah, sure. So this is just kind of a quick, I'm going to run through these slides fast. It was a presentation that I did at the ALTI show on sound cards for audio tests. So there's a little bit of history in here. You can go to the next slide. And so some sound card history, some audio test equipment markets, pros and cons about traditional sound cards. And I've already talked about who Echo is and where we came from. And then we'll look at the Echo test system. So some of these I'm going to blow through pretty fast. So these are the founder, Milo Street. He's the guy that dates all the way back into the 70s with the company. Founded as Straight Electronics. And,
these are completely contemporary and up-to-date pictures, by the way.
Yeah. So this is our main core company right now. It's the three of us. All right, go on to the next one. So we make, design, and engineer audio test and measurement systems. That's what we do as a company, and primarily the test and measurement hardware at the moment. Let's go ahead to the next one. So there are a bunch of different kinds of audio test equipment out there. There's software analyzers where you need hardware to go with it, just software only. There are audio analyzers, which are combined hardware and software, but they're proprietary, right? They all work as a unit. You can buy audio DACs, which are just the hardware, but you need software to go with it. And usually those software analyzers, and I'll use an example like National Instruments, right? They make the software, but they also make DACs to go with it. And you kind of have to work the two of them together. They work as a pair. You can't really use their audio DACs with the other software. And then go ahead and hit the button again. There should be a third one here, sound cards and audio interfaces. So if you're on a budget, you can use a typical sound card. It's just A to D and D to A converters, right? And they're high quality. So you can use sound cards and audio interfaces as the data acquisition side of an audio test setup. You just need to have audio analysis software, test and analysis software to go with it. And there's a lot of, kind of off-the-shelf, inexpensive software packages you can kludge together. But the idea behind what we're making is to take the inexpensive sound card A to D and D to A converters and expand on that and add the right spigots, the right inputs and outputs for the test and measurement world. People need more than just line outputs. They need amplifier outputs for doing acoustic testing. They need headphone outputs for testing headphones. And they need different kinds of inputs and input levels. And they need microphone conditioners for CCP microphones. And they need TEDS readers for TEDS microphones. And these are all things that are kind of indigenous to the test and measurement world, but not necessarily to the audio production world. So a typical sound card doesn't give you all these items. And you need to go out and buy them and kludge them all together into a system to get it to work. So we put it all in one box.
Just out of curiosity, I always like to understand the acronym AIO. Does that have something to do with in-out based on what you've been just telling us?
That name has a lot of meanings. So Matt can give you a little bit more enlightenment on that one.
You know how DVD was originally digital video disc, and then it was digital versatile disc, and they said, it's just DVD. We're not gonna. It's kind of like the name has evolved. It was originally the all-in-one because I was alluding earlier to the Firewire box with the broken jacks in it, and so. What they had in addition to that was they had an external microphone conditioning amplifier, I think, and then an external amplifier to drive a speaker. So they had a bunch of other gear they're hooking up to our box. And so we said, let's just put it all on one case for you and get rid of the interconnects. And we'll take off the power switch and a bunch of other things that are just more points of failure. And so the idea was it was the all-in-one. You're taking all of that gear and you're putting it in one. And that's the AIO. I think it was the acoustic IO at one point. And now it's just the AIO, because then we started adding digital interfaces to it, and the A didn't just mean acoustic anymore. I guess you could go back. Yeah, so it's the AIO.
Okay, thanks. Sorry.
So it means whatever you want it to mean.
It was an acronym that just became its own thing.
All right. Carry on. Sorry, Chris.
No, it's
so
good.
On the box that you see the picture of there, every single connector is a locking connector, because the original design was for production test, end-of-line production test. And even the power connector is a locking connector. So you can't accidentally pull it out in the middle of a production run on a line. So we tried to design this purposely as a very simple box that didn't require any user input or output to the box itself. Everything is done in software control and with locking connectors on everything, so that it was virtually indestructible as a setup.
It was almost as a process of removing things from the box as it was adding things to it. I'm going to jump ahead here just a little bit, Chris. And if we go back to this guy, it's got a power switch, it's got word clock connectors, it's got MIDI, it's got a bunch of LEDs on the front and stuff like that, telling you what you're sticking to, what your levels are. None of that was important. In fact, those were detriments. They needed, and so a big part of the design was actually removing the power switch, removing everything extraneous, everything that could fail that you don't need, and stripping it down for the factory environment. That was a big part of the work.
Right. So these next slides that he just kind of breezed through there are really history slides about sound cards. And this was part of the presentation I did at ALTI. So early desktop computers, and we started out, as Matt said, making a speech synthesizer for the Apple II computer.
What's the one in the lower right corner? I don't recognize
lower right? IBM PC.
It's an IBM. I can see that.
Yeah.
Okay, wow.
It's the original IBM PC.
Wow.
Anyway, next slide.
Yeah.
So the Apple II, and the thing with the Apple II that's made it stand apart and really made it take off as a computer was the fact that it had expansion ports in it. And so people could make up their own cards and put them in there and get away with it and add to the functionality of it. And so that really kind of started off the whole sound card idea. Next slide.
You want to step through? Okay, yeah. I know this goes back. This is going back a minute here.
Yeah, so on your left up there, you see an Echo speech processor. That is the little sound card that went in the Apple II, the original Echo product.
It was so successful, we renamed the company after the product.
I see it gets labeled with an Alberta school logo, which is where I went to high school.
Okay, yeah. No, it was a big. But yeah, this is back in the day. I think this was all hand built, here in California. I think there was one that was like a wooden case. It's like practically runs on steam and needs to be serviced by a qualified blacksmith. I mean, it's really, really going back.
Cool.
Yep. Okay, next one.
Okay.
And then of course the PC kind of took over the market because it was even cheaper and had more expansion ports in it. And you could do more with the IBM PC case than you could with the Apple. Just a little more open. So that led into, go ahead to the next slide, led into modern audio interfaces, which is just taking those sound cards, sticking them in an external box with some input and outputs and controls, and then having a connection to the computer. And the connection to the computer is typically USB, or Firewire in some cases.
Not anymore.
Yep. So the next slides, I think, are more on the markets and the market segments. So we have the DIY market, and you can breeze through these pretty fast. Lack of budget, they want minimal.
Sorry.
That's all right. There we go. Prefer a minimal solution to fit their exact need rather than a general purpose test box like an audio analyzer. But they're really keying off of minimal solution and cost. In the DIY market, but it's a large market. There's a lot of people out there doing testing. Next one is just the software-driven market. This is kind of a general overview. You have to hit a bunch of buttons here, Mac, because I had it kind of queued up for. There you go. Go back one.
Sorry, it's. I don't know when it goes to the next slide.
Right there. Okay. Stop. So this is just talking about audio testing. That it's a stimulus, and that's usually hardware collected. Or hardware generated, some kind of a stimulus. You have acquisition, which is hardware collection, and then you have analysis, which is software. And you can easily kind of separate the two. You can have software-only audio analysis testing packages that use just off-the-shelf hardware. That's the sound card and audio analysis software package idea. But most of the testing today is really software-driven. I mean, if you look at any of the audio analyzers like Audio Precision and others, their software is just huge and it does everything. It covers all cases, all use cases. And the same with Listen Sound Check and others that have been in the business for 30 years, and they've been developing their software for 30 plus years. And it does it all, really. It's software driven as far as the features, that we're used to now in audio analysis. So hardware just kind of comes down to, do you have the right inputs and outputs, to get that data into the computer for the analysis side. So go ahead to the next one. So I kind of like throwing this slide up. I used to be in the pro audio industry and service large mixing consoles for recording studios. And this was my test kit, the basic test kit. So you had individual pieces of test equipment, digital multimeters, you had sine wave generators and a little oscilloscope. And if you're really lucky, you had a distortion meter or something like that to go with it. And now all of that really is encased in, in a little piece of software and an audio interface card. And it does pretty much the same thing. Go to the next one, Matt. So let's talk about costs for a second. Audio analyzers, of course, are the really expensive software, hardware, everything dedicated, everything proprietary, and the highest cost. And I came from that world before I came to Echo at Audio Precision. So large audio analyzers are expensive, and they're really, really good. They're the best equipment, the best hardware, and the best software. Okay, go to the next one. The next one would be a combination of proprietary DACs and some kind of test software. I use the example of National Instruments, but pretty much all the big noise and sound and vibration companies have DACs for acquiring audio signals. And then they have their analysis software, which some portion of it is dedicated to doing audio analysis and some portion to vibration analysis. But that idea of having proprietary DACs and software would be kind of the next level of expensive audio test equipment. Okay, next, go ahead. So on the bottom end, you've got the audio sound card and some kind of PC test software. And an audio sound card can be fairly inexpensive, and you can go out and get shareware for testing, or you can get a very inexpensive package for a few $100s, and you have a basic setup. It's not the best, but it may be good enough for what you're doing. So a lot of the use case drives what kind of equipment you end up getting. If you need something really inexpensive just for some basic acoustic testing of some cheap speakers, you don't have to spend a lot. You can get a basic sound card and you can get some basic software and you can get it done, right? And a fairly inexpensive microphone. Where we fit in is kind of in between the proprietary DAC world and the audio sound card world. We have way more features than audio sound cards. And in a lot of cases, we have way more physical features than proprietary DACs, different kinds of inputs and outputs that they don't have. But we still require external PC test software to run the acquisition and analysis. We are making the hardware and not the software part of it. Okay, next. So some of the pros and cons, and I'll go through these really quick. The pros of traditional sound cards is they're cheap. They have multi-channel I/O. They're quality A to D and D to A converters. This is all really good stuff. They use an ASIO interface, which is nice because you can get a lot of channels out of it. Okay, next. The cons are they have the wrong connectors for test applications in virtually every case. They're usually line output only. There's no amp outputs or headphone outputs for monitoring. Okay, there's the input side. There's no CCP power or TEDS readers for using test microphones. So they rely on cheaper mics. No impedance measurement capability built in. There's no sense resistors built into a sound card that allows you to do impedance measurements. Go ahead. They're not modular. They're not calibrated. And there's no software control of the hardware from an external program of any sort. So if you buy a sound card of any sort and you hook it up as a test instrument, you're fixed with whatever that sound card's set at. You can go on the front panel, you can make some changes to it, but there is no ability to go in the test software and set up an automated test routine that changes the hardware settings on the fly during a test routine. And that's very often a needed case, right? Turning something on and off, or switching to another couple of channels, or whatever it is. That there's no ability on sound cards to do that with external control of any sort. We built ours as a test instrument, so we have a command line interface and an API that allows us to be controlled by the test software. And that's a real key point. Okay. Next one. And then let's see, the audio test equipment R&D market is the one that drives the audio analyzers. You can go through this pretty quick, Matt. Just go ahead and the scope of it covers all audio products and markets. R&D covers everything, right? You have to design everything. You have to build everything. The R&D side literally is every possible corner case you can imagine. We used to have a joke at AP that no two customers ever used our equipment the same way. It's just crazy how many use case scenarios they come up with. But it's really driven by extreme performance and the dynamic, extreme performance range. So you have all the way from dynamic microphones all the way up to power amps. So from almost, a couple microvolts up to 300 volts, you have to be able to take into an audio analyzer and be able to do something with that. So the dynamic range of the instrument is phenomenal. But that's the R&D market. Let's move on to the next one. So the production test and verification market is where we firmly live, and that includes QA and QC of items that you may be purchasing to go into your system or evaluating. So go ahead and hit a couple of these, Matt. Catch up with me here. So the idea is the test equipment needs to verify the minimum performance standards for whatever it is you're testing, a golden sample, setting test limits. It just needs to verify that it meets the performance standards. The scope covers all electroacoustic components and subassemblies. It's cost sensitive at higher throughput and typically cheaper end products in the QA QC verification market. So keep going. It's repetitive testing, and this is different from the R&D market. The same component or device is tested over and over and over again. So you have to have a automated sequence of testing that you can run if it's a complicated test and just go over and over. If it's a real sensitive test where you're just putting a tone in and just checking a level, then you don't need a sequencer, of course, but still it's repetitive testing. And it's time-sensitive testing. The faster the throughput, the more money you can make as a company, right? So automation control is pretty critical, and it's low test complexity. It's usually simple pass-fail for the user interface. It's non-trained operators, right? So the idea behind production test and verification is to quickly test the same products over and over again, get pass-fail criteria on it, maybe some additional information if you really need it, but mostly you're just interested in knowing that you made a product that works to spec and you're putting it out.
All right.
So speed and cost. You can go ahead and pass this one. Just go to the next one. This is just some more breakdowns of the markets. So let's get to the AIO test system. So here's what we make. It's a 2-module box. So you can put 2 different modules in it of different types. We currently make 7 different module types. So it's expandable to a point. We can go up to, with our analog input modules, we can go up to 8 analog inputs maximum on it. We do have some digital modules and control modules as well for various scenarios. Go ahead to the next one. So I told you earlier on that we support any external third-party software that supports ASIO, Wasapi, or Core Audio. Those are the interfaces for the PC is Wasapi, Core Audio is the Mac, and ASIO is kind of the professional interface that was designed just for doing this kind of stuff for large channel counts. So the test software that you need to work with something like our hardware, you can use any of these listed, and then there's probably another 20 or 30 that I didn't list. These are just kind of the common ones. But they all work with either ASIO driver or Wasapi or Core Audio. And so they can work with our hardware. So we just show up as a USB device on the computer, or an ASIO device on the computer, and with the right channels already put in and the channel names on there, and you just route your signals to us and go. It's quite easy. Okay, next one. That's it. So that's kind of the overview of the product and why we exist from the sound card days up until now.
Okay.
Yeah.
I'd be curious. Wonder if we could tell us a bit more about what's involved in this USB audio stuff. So DAX, ADAX, USB interface.
Sure.
Oh, that's pretty. Yeah, sure.
You want to take that one?
Sure. It's. I mean, the fun thing about it is, I can probably even do a little show and tell here. It really, from the computer's point of view, it's just a sound card. So, like I'm on this MacBook here. The Mac has built-in support for USB Audio 2, so that's no problem. And I'm stalling, so I'm looking for the cable that's got the adapter. There we go. Because it's a Mac and it's got USB-C.
Right.
And I'm just going to plug in my Mac. I've got an AI unit here. I don't know if it'll come up on the camera. It's got the blurring. Anyhow, that's. I mean, you guys have seen the USB device get plugged in before, so it's not that exciting. But it's just a USB 2 class compliant device. So the point is, this is boring, but it's supposed to be boring, right? It's supposed to just sort of happen, right? Which is that I'm going to. So if I share, if I just go into my devices here on my Mac, you can see, I'm just going to go to allow that, and it's going to come up. Hopefully, and there it is. It just came up. So the Mac just thinks it's another sound card on the computer, and it works the same on the PC. You can plug this into the PC. You can it'll just come up in the system tray, and you can say, "Oh yeah, play audio out through that," and that's fine. Or it's got an ASIO driver. It's sort of boring. It's that's sort of the point, right? Is it just sort of works and does its job. You don't have to think about it too much. And so it works just like if I have these. I have these USB audio headphones that with a microphone, and you just plug it in and it just works. It's the same thing. It just uses the built-in driver in the system, and it's fine.
So you mentioned that, especially for the audio stuff, it has constant current supply for those types of microphones. So you have another whole front end section in the design to handle that part of it.
Where we can kind of talk that, I'm going to pull up the website here just because I think that'll be instructive for what you're asking about. So there's 3 modules in the device. It's just a sort of standard 1U rack mount thing. We have this bit in our website here that lets you play with the configuration a little bit. Let me just pull that up so it looks nice. Okay. And so this is the thing on the website where you can play with a sort of build your own AIO system. And so the part I think you're asking about is on the left there, what's like with the AIO interface module. Again, pretty simple. It's just got the microprocessor in it. It's got the USB audio interface. It's got power, and then there's a grounding screw. And then as far as what you're asking, like for example, we put up our A module. We'll throw that in the center slot there. That's got the TEDS microphone inputs. That's got the IEPE. That's got the amplifier outputs. And so that's a discrete module that can be, so you can build different configurations for the system. Like here, we'll add one here that's got a line level output. It's got those same IEP inputs on there on the right, on the left there, but then it's got the balanced line outputs on the right. So so to your point there, the audio modules that are in the center and the right-hand slots are separate from the USB interface, and there's a backplane that glues it all together.
Oh, interesting. And you're talking about configuring it over some APIs. Can you set things like input gains on the microphones, things like that?
Yeah. The microphone gains have 3 gain stages, 20 dB apart, and you can either do it with. We have a control panel app that's got a GUI that you can click on, or we offer all the same things. It can all be scripted. We have a command line app where you can just type in, Echo AIO microphone 1 gain equals 10, that kind of thing. Yeah. Or and then there's another layer to it where we have a shared library where if you want to write your own software, it's got a a C level interface where you can just call in and, you can call it from Python, or you could call it from your own app, whatever you want to do. So there's sort of multiple, you have the sort of the high level control with the graphical user interface, the middle level with the command line, and then the lowest levels, we just give you a straight programming API if you feel like rolling your own software.
Yeah. And amplifier outputs, what kind of power level are we talking about for
10 watts?
10 watts, yeah.
Yeah, I think, yes. That's a 60 watt power supply on the box total. And so we can do 10 watts continuous, I think, into 8 ohms for each. It was originally designed for smartphone testing. So you're not looking at a lot of juice for testing something like that. And I think it was just to drive, you picture a test chamber with the phone suspended inside it and the speakers around it was for driving those speakers. So yeah, it's not, you're not gonna drive your Marshall stack with it or anything like that, but
And so also for an impedance measurement, you mentioned that if you want to measure the impedance. Oh
yeah. Well, here we've got
a different module, is it? I see. Okay.
Yeah. There we go. Yeah. Yeah. We originally, yeah. So it's a typical thing with the 4-wire kind of impedance measurement style there. So you can you wire up I don't know if this is how clearly visible this is here. There we go.
Oh, there we go.
Yeah, so essentially you just wire up these two terminals to one. You wire up these two pins on the connector to one speaker terminal, the other two pins on the speaker connector, and I have a diagram that actually probably makes this a little clearer if you just bear with me for a second.
Another ADAC channel internally that's your sense channel that you can't otherwise connect to.
Oh, you're stealing my thunder. Yeah, you're absolutely right. Yeah, that's exactly right. I'm just being a little slow here. Echo team folder. Yeah, that's essentially, you're exactly right. Can you see that graphic there?
Yeah.
Yeah, so you can see there, it's got an internal current sense resistor right here, this 0.1 ohm resistor down here. And you can see there the amplifier's driving out. We're doing the 4-wire connection to the speaker. And then there's two, the Zoom thing's in the way. You can see there that on inputs 3 and 4 in the ADC, one of them is the voltage input, one is the current input. So that's, so most software will have a place where you can say, well, this is my vSense input. This is my, my current sense input. This is my voltage sensing input. And you're just dividing the two, and that gives you the impedance directly. Yeah. This is nice because there's no external current sense resistor required. You just wire the speaker up and you're done.
Yep. And very small value.
Yeah. Again, this isn't, intended for, it's intended for, smartphones and tablets and the like.
Sure.
High watt stuff.
No, very good.
Yeah. So that's and I think that's it turns out you can do this kind of thing. We found out later that, to Chris's point about how customers never do what you think they're going to do, and we found out that they were also using it to test haptic actuators to pre-qualify those. We didn't know. I was like, it was pretty good.
Matt, can you go back to the configurator for a second?
Really?
And then do the C module on the right.
Sure.
So we've also added some control modules that really don't have any audio in them at all. They're just designed for other control signals that you may need for doing testing. So this one, for instance, has a 5-volt adjustable power supply that has a current monitor on it. So you can use it for battery simulation. You can set it whatever you want, check the current, and then raise it or lower it, to simulate over voltage or under voltage conditions of the battery and see what that does to your DUT. It also has GPIO, 8 channels or 8 switches of GPIO in and 8 outputs. So you can use it to, let's say, trigger light bars or pass-fail indicators in a production test environment, or trigger other pieces of equipment, like opening a chamber so that you can reload it, that type of thing. And then on this one, we also have a PTH sensor, pressure, temperature, and humidity sensor that allows you to get kind of baseline factory environmental stats before you make a production run, which is pretty important with certain kinds of paper cones on speakers and things like that. They're pretty sensitive to the environment. So there are other modules besides just the audio testing modules that give you the ability to configure a complete system, kind of like you would get if you bought an audio analyzer, a full audio analyzer.
Yeah, I really like your website, the way people can come in and configure it like that. It's
Yeah, that was fun. That was fun to do.
visual to it.
Yeah, well, it's trying to get across all the various combinations and.
Yeah, actually, as a test for what we wanted to do, we were looking at one of the guitar websites where you could choose the color of the guitar and have it pop up, and
Easel.
yeah, it was great.
All
So
right.
we decided to kind of do that same thing.
So if you want 8 channels, you put in 2 4-channel modules. Is that how it
Correct.
works?
Yeah, go with a A2. So if you put in 2 A modules,
Yeah.
down below it says it's an A2 configuration, and it'll actually tell you all the stats about that configuration, how many mic line inputs, how many amp outs, and take you to the data sheets and things like that. So we tried to make this kind of an intelligent page. Whatever you configure on the page graphically, it will give you the descriptions.
Nice.
If you started with a module with a unit with 1 4-channel module, later on you plug in another 4-channel module, does it enumerate as an 8-channel USB as opposed to a 4?
Yeah,
Yes.
it does, but you may have to have it recalibrated.
Okay.
But yes, you can.
Yeah, the each one of the boxes, the brain in the box looks at what modules it has, and then
Okay.
configures
So
that
that's-
as one USB device.
Right.
Yeah, and it'll change the channel names and the channel counts and all that accordingly. Yeah.
Yeah,
All
so
right.
it's pretty dynamic. And then the last thing, if you go back up, Mac, to the picture, we do actually have some digital modules as well. On the right side, you can change that one to a T module, and we have a 10-channel TDM module. So now you can get I2S signals or TDM signals in and out, and connect up to some digital equipment as well. And the idea with the AIO in general was to keep adding modules as we got more demand for certain use cases.
Right.
We can pretty much do anything we want with it.
Okay. Hence the mobile phone and audio over Ethernet and all kind of the markets you discussed earlier. As they expanded, you guys expanded with them.
Well, we kept reinventing, but the nice thing, a lot of this was all built on the USB audio stuff. Was actually, we originally built a guitar USB audio interface, and so we learned how to do that.
Cool. All right. Okay. Anything that you guys at Echo want to add before we wrap this up?
Yeah. Anything?
I think this is a good.
It's just good to be here. It's a pleasure.
Good place to stop.
It's a good.
We were just really. Oh, I think we were just very thorough. It's been It's always kind of fun to go back through memory lane. But yeah, I think we covered everything.
Simon, any more tough questions to wrap it up?
Nothing more from me.
Let us have it. Go on, come on. Enough with the softballs.
No, that's excellent. Thank you.
Okay. All right. So let's see here. Okay. So thanks guys for joining us today. We really appreciate it.
Thank you very much.
Put some information down below for everybody the link to the website, all that good stuff. And subscribe, share this around. This is a very technical podcast. We don't get a lot of views, but I can tell you that you guys won't believe it joining us today, but they watch most of it. The people who do log in.
As long as they're the right views.
Yeah, it's exactly right. So thanks everybody for watching, and we'll see you all next week. See you guys.
Thank you very much. Thank you so much. Bye-bye.